Right, so NVIDIA just dropped something absolutely massive. And honestly, most people have no idea what it actually means. We're talking about a shift that could completely change how AI develops over the next decade. And no, this isn't another hype train. This is real. This is NVQ Link, and it might just be the Rosetta Stone moment for quantum computing and AI working together. Look, I know quantum computing sounds like sci-fi nonsense that's always 10 years away. But here's the thing. What NVIDIA announced back in October isn't about building a better quantum computer. It's about finally making quantum computers actually useful by connecting them to the one thing they desperately need: AI supercomputers that can babysit them 24/7. Because here's the dirty secret nobody talks about. Quantum computers are brilliant, but they're also incredibly fragile and make mistakes constantly. Without help, they're basically useless. Let me back up for a second. Your laptop, your phone, everything you're using right now runs on bits. Zeros and ones, on or off. It's simple, it's reliable, it's been working for decades. Quantum computers use qubits. And here's where it gets weird. A qubit can be 0, 1, or both at the same time. I know that sounds mental, but stick with me. Imagine you've lost your keys somewhere in your house. A regular computer searches room by room. Kitchen, nope. Living room, nope. Bedroom, found them. That takes time because it's sequential, one after another. A quantum computer is like having clones of yourself searching every room simultaneously. You find those keys way faster because you're checking everywhere at once. That's superposition, and it's the reason quantum computers could solve certain problems in hours that would take regular computers millions of years. Now, you might be thinking, brilliant, let's just build quantum computers and solve everything. Not so fast. Here's where the conflict starts, and this is the bit that's been driving scientists absolutely mad for years. Qubits are ridiculously fragile. We're talking colder than outer space, -450 degrees Fahrenheit. One tiny vibration, a bit of heat, even looking at them wrong. And boom, your calculations turn to garbage. They make mistakes all the time. Imagine typing on a keyboard where there's a 1% chance every letter you press comes out wrong. You'd end up with complete gibberish. That's what quantum computers deal with constantly. These errors pile up so fast that without constant monitoring and correction happening in microseconds, millions of times per second, the whole thing falls apart. And here's the real problem. Quantum computers can't fix their own errors. It's like trying to proofread your own essay. You wrote it, so you're blind to the mistakes. What they need is help from really powerful regular computers running advanced AI algorithms to watch what they're doing and fix errors in real time before they ruin everything. But for years, scientists have had quantum computers over here doing their thing, and AI supercomputers over there doing their thing, and there was no good way to connect them fast enough. It's like having a Formula One race car and a world-class pit crew, but the pit crew is in a different country. The car can't perform without constant adjustments, but if it has to fly across the world every time it needs help, it's never going to win the race. That connection, that bridge, that's been the missing piece, and that's exactly what NVIDIA just built with NVQ Link. On October 28, 2025, Jensen Huang stood on stage at the GTC conference and called it the Rosetta Stone of computing. And honestly, he's not wrong. NVQ Link is a superhighway connection between quantum processors and NVIDIA's AI supercomputers, and it's insanely fast. We're talking microsecond delays. That means the AI can monitor the quantum computer and fix errors almost instantly, before they even fully happen. It's like having a spell checker that corrects your typos as you're typing them, not after. And here's the clever bit. It's not just for one type of quantum computer. Some companies are building quantum computers with superconducting qubits. Others use trapped ions. Some use photons. NVQ Link works with all of them. NVIDIA announced 17 different quantum computing companies, and 9 major US national labs are already on board. But why does this actually matter right now? What can we do with this that we couldn't do before? Well, researchers at Berkeley Lab and MIT are already using NVQ Link to simulate how proteins fold and how molecules interact. That might sound boring, but protein folding is the key to understanding Alzheimer's, Parkinson's, cancer. With these systems, they could discover new treatments in months instead of decades. Teams at Yale created something called a quantum transformer, and they're using it to generate new molecules with specific properties. Imagine designing a material stronger than steel, but lighter than plastic, or a battery that makes your phone last a week on a single charge. Pacific Northwest National Lab and Oak Ridge are running climate models way more detailed than anything we've had before. This could help us understand exactly how climate change will affect different regions and what we can actually do about it. And then there's AI itself. Right now, we're hitting walls. Training large AI models requires insane amounts of computing power and energy. Training GPT-4 reportedly cost tens of millions of dollars and used enough electricity to power a small town for weeks. To make AI better, we need to make it bigger, which requires even more power, more money, more energy. It's not sustainable. We can't just keep building bigger data centers and consuming more electricity. We need a smarter way. That's where quantum AI hybrid systems come in. Certain parts of AI training, like processing huge data sets or finding patterns in complex data, are exactly what quantum computing excels at. With NVQ Link connecting them, we could potentially train AI models in hours that currently take weeks. More data usually means better AI, but regular computers can't process it all efficiently. Quantum computers process enormous amounts of data simultaneously. Imagine training a medical AI on every research paper ever written, every patient record, every clinical trial, all at once. The AI we could create would be incredible. Now, I'd be lying if I said this was all sunshine and rainbows. There are real concerns. If AI becomes exponentially more powerful, it could do jobs humans currently do. And we're not just talking about routine tasks. We're talking creative work, analytical work, scientific research. History shows technology creates new jobs, but the transition can be brutal. Quantum computers cost tens of millions of dollars. This technology will be accessible to big tech companies and governments, but not everyday people or small businesses, at least not yet. That could widen the gap between those with access to cutting-edge tech and those without. And there's the encryption problem. Quantum computers could potentially crack the encryption protecting bank accounts and government secrets. Scientists are working on quantum-resistant encryption, but it's a race against time. Here's the uncomfortable truth. Even the scientists working on this don't fully understand all the implications yet. We're building tools more complex than our current understanding. Jensen Huang himself said practical large-scale quantum computing is still probably 15 to 30 years away. So while NVQ Link is a major breakthrough, we're not going to see quantum computers replacing your laptop anytime soon. But make no mistake, this is the beginning of something huge. The payoff at the end of this conflict arc is a future where quantum and classical computing work together seamlessly, where AI advances in ways we can barely imagine right now, and where problems we thought were impossible become solvable. That's the future NVIDIA just unlocked, and honestly, it's closer than you think.